So the last couple videos have been looking at naming ionic compounds. And all of the compounds that we've had so far have only two different elements. The compounds we're going to look at here are a little bit different because they have polyatomic ions. Now remember from a previous video, the prefix poly stands for many or more than one. So we're going to have an ion that's made up of more than one atom. Okay? So here we've got a list of polyatomic ions. This was actually the table in your textbook. In class, you'll be given this sheet. This is the one that we'll actually use that I expect you to know and memorize. We should have memorized them in honors chem, but you'll want to make sure you know these now in case you forgot, because for some of us it's been a while. Make sure that you study these, memorize them, learn them, because on the AP test, on the tests in class, what I'll say is I'll just tell you it's sodium acetate, and you'll need to know what acetate looks like and the charge. Or I might just give you the ion and you'll need to know the name, okay? So make sure we learn these. So what a lot of polyatomic ions are is they're called oxyanions. So remember, an anion has a negative charge. So it's a group of atoms with a negative charge that contains oxygen. Okay? So oxyanions have different numbers of oxygen atoms. Now some of these form series. So for example, we have SO3 with a 2 negative and SO4 with a 2 negative. I've got NO2 negative and NO3 negative. So we can have series. Over here, in fact, we've got lots. ClO, ClO2, ClO3, ClO4. So series, okay? Now here's the way it works. The name of the one with the smaller number of oxygens ends in ite. So SO3 and SO4, SO3 is sulfite. NO2 and NO3, NO2 is nitrite. The larger one ends in ate. Okay, so SO4 is sulfate. NO3 is nitrate. So the little one is ite, the big one is ate. Okay? Now, in the case over here, we've got more than two, it gets a little bit trickier. Now we're going to have to put prefixes into the mix. So if you notice, this still has the least number of oxygens, so it still ends in ite, but because there's more than two, I add this prefix hypo. Hypo means less than, okay? Down here, I've got the most number of oxygens, so it still ends in ate, but because there's more than two, I add this prefix per, which means more than, okay? So ite is less, ate is more. If you've got more than two, we need prefixes. Now, naming ionic compounds with polyatomic ions is pretty easy. We use the exact same rules we used before. If we know the charge, no Roman numerals. If it can have more than one charge, Roman numerals. And then I just look at the polyatomic ion, and whatever the polyatomic ion is, I get its name from the table. Okay? So here, I've got Na. My polyatomic ion is SO4. So Na is sodium. I'm not going to use a Roman numeral because I know that sodium's always a +1. SO4, if I look at the table, is sulfate. Now I don't change the endings. There are no ides. I don't do that. I just leave the name of the polyatomic ion the way it is. Okay? So the second one's a little bit trickier, okay? Think of it as groups. I'm always going to have something that's positive and something that's negative. And my positive, I can't have more than one positive element unless it's a polyatomic ion. So this whole thing is my polyatomic ion. If I look up at my table, H2PO4, it's a polyatomic ion. I want to be careful because I could have HPO4, or I can have H2PO4, or I could just have PO4. So be careful on those, okay? So H2PO4 is its polyatomic ion. So I start with my first element, my metal, which is potassium. If I look at the periodic table, potassium is an alkali metal. It's always a +1, so it does not need a Roman numeral. Okay. H2PO4 is dihydrogen phosphate. I don't change anything with the ending. I write it exactly as it appears here. Okay. Let's try one more. So here I've got Fe, which is iron. However, Fe is a transition metal. Sometimes it can be a +2, sometimes it can be a +3. It changes. So I'm going to leave room for the Roman numeral. I know NO3, if I look at my table, is nitrate. I misspoke. Okay. So now I need to figure out the charge on iron to put in the Roman numerals. Okay. So if I look here, nitrate always has a -1 charge. And I've got 3 of them. Remember, this one goes across. I have 1 iron. This 3 goes across. That 1 iron has a +3 charge. So I would name it iron 3 nitrate. Okay? So take a second, try D. Try D. Make sure that you're looking at your polyatomic ions. Try E and F as well. So Mn is manganese. If I look at the periodic table, Mn, look, it's a transition metal. I need the charge as well. Mn needs a Roman numeral. OH is my polyatomic ion. It's right here. It's hydroxide. So now I have to figure out what goes in parentheses. I've got I've got OH. OH has a charge of -1. So that -1 comes down here, and I have 1 Mn. I've got 2 OHs. I'm going to bring that up here. So it's going to be manganese 2 hydroxide. Sodium we saw before does not need a Roman numeral. So I should have named this sodium. My polyatomic ion is sulfite. It's the smaller of the two. 4 is 8, 3 is 8. Again, sodium doesn't need a Roman numeral. CO3, if I look at the table, is carbonate. Okay? Now the formulas are a little bit harder because now we need to keep track of our charges again. So I've got sodium, hydrogen, carbonate. Sodium's Na. If I look at the periodic table, it's always a +1. Hydrogen carbonate is my polyatomic ion. If I look up at the table, HCO3, hydrogen carbonate, has a charge of -1 as well. So, +1, -1, when the charges are the same, I squish them together. NaHCO3. I still have to have this subscript because my polyatomic ion has the subscript. If I don't have the 3 here, then it's not my polyatomic ion, it's not hydrogen carbonate. Okay? Cesium perchlorate. Okay? Cesium is Cs. If I look, cesium is always a +1. Perchlorate is my polyatomic ion. Perchlorate, ClO4, -1. Again, +1, -1. When it's the same, I squish them together. CsClO4. I need to keep this 4 because otherwise it's not perchlorate. Now what if the charges don't match? Ca is calcium. Calcium's an alkaline earth metal. It's always a +2 charge. Hydroxide is my polyatomic ion. Hydroxide is a -1, OH with a -1. So just like before, when charges don't match, we switch them. So the 2 goes in front of OH, the 1 goes in front of Ca. So since I left Ca alone, I only need one of them. I don't show anything here. But I need 2 OHs. If I write it just like this, though, it's incorrect. The reason that it's incorrect is because I need 2 of this entire polyatomic ion. The polyatomic ion has the -1 charge, so I need to show parentheses. Okay? Anytime you use a subscript other than the original one for a compound with polyatomic ions, it must have parentheses. Okay? Take a second and solve example D. Now, it's important to remember that all of these so far are ionic compounds. Make sure you're keeping track of charges.